You got flat, well, assuming it is on flat land, you got a cannon. It's bolted to the ground. Oh, it's kind of wrong, but, you know. When that fires, that momentum will be, like, passed on into the ground and going that way. If it's going that way. Even though that don't move, I suppose the whole earth would. Didn't actually think about that before, that's quite weird.
The pre-tests were, it was agreed, a good form of collecting data. The challenge was to develop a wider range of ways in which teachers and trainers can collect evidence.
I think, I mean, I would have done exactly the same, to be honest, but, you know, looking at a way to relax the students a bit more, and maybe a statement at the start to say this is not a test. Yeah. You know, something in there to relax them. This is not a test for you, this is just to see what knowledge you have, so we can teach you better in the future, if you like.
Say the test's useful if you're trying something different and you want to you need to assess prior knowledge and you need to assess knowledge after the method you've used, because you've got numbers that you can hang something on, and it looks like you've got data, and it may reflect it properly, it may not. But you've got to listen to them and get some dialogue going, otherwise you don't even understand the context or why they've answered that. It's all very well them saying B. Okay, 15 out of 20 said B. So what? Why did you say B? You can't get that off a test. You've got to set up some dialogue. You've got to get them communicating in a group.
I think one of this a good starting point this might be, is if you wanted groups to sit and have a discussion. You give them a practical example, explain a practical example, or show them a video of something and say, why do you think that happened? And then just sit there and let them talk to each other.
There must be plenty of MPEGs we can get our hands on to put on a PowerPoint and say, watch this.
And that's like, picture in a truck stopping at traffic lights as soon as you mentioned it.
We've got to look at a practical situation and get them to come up with their thoughts most of the time. Listen to their thoughts at the onset of a lesson, if you like. You can see what they know from that just by going around, and then you know, just facilitate and really just listening to where they are.
And try and ensure that the task develops as much evidence itself that they've actually learned something.
I think one of the other important points is not only are we there to sort of teach them, they're there to sort of teach us, but not when they give us feedback, they've got to know that we're actually going to listen to it. There's no point in them saying, well, we like it done like this, we like it done like that, if nobody's actually going to listen to it and act on it. They want to know, they want to see evidence of us doing something to help them, rather than just us doing it to help ourselves or to make our lives easier. We should be doing what makes their learning better.
This sequence has been devised to promote discussion about learners' ideas, how they express them, and how we interpret their explanations. To use this sequence most effectively, refer to sections in the accompanying teacher and trainer resource. This provides a framework for discussion, along with analysis and suggestions for building on the work featured. Users may wish to use this sequence for different purposes. We anticipate users will view the sequence several times in any one session. The teachers and trainers featured are at the beginning of a process of professional reflection. We are grateful to them for allowing us to share in the early stages of this journey. The electric motor provides a focus for this exploration, but any phenomena from the field of engineering could be used in a similar way to illuminate these ideas. Electric motors, and more importantly, how learners make sense of them, was just one of the areas that teachers and trainers chose to explore. Understanding the motor effect draws on more than one concept, and like most topics in engineering, the experience of a range of applications.
It's changing me.
Teachers and trainers devised activities around these simple components that would engage learners with the fundamental concepts. They would stimulate discussion. But how to use these effectively in developing learners' understanding?
Think about the main parts that create movement. You've got a couple of magnets and you have a nail.
Teachers and trainers tried this activity with learners either as an introduction, a review, or a way of extending understanding, making connections with other activities that learners are likely to encounter. Linking these helps to raise questions about the basic principles.
I think what I like about this one, it can be used in lots of different situations, and I think it makes active learning. Students get their hands on it, and they can put them more together and link it to the theory.